For questions 2, 3, and 4, I'm still factoring out the GCF. So in question 2, I have two different terms here. And the GCF, for the regular number, for the coefficient, I'm asking myself what number, or what's the largest number that divides in evenly into both 27 and 18. And that would be 9. For the x's, how many x's can I take out of both of them? Well, I'd like to take out x squared, but this one only has just one x, or a single x. So I can only take out a single x. With the y's, this one has 3 y's, this one has 2 y's. I'm only as strong as my weakest link, so I can only take out 2 y's, or y squared. So that is my GCF, and I need to now write what's left in both terms after I factor out 9xy squared, or after I divide by 9xy squared. So you can say factor, some people say divide, some people say we're just pulling out this number. There's many different correct ways to refer to it. So 27 divided by 9 is 3. With the x's, I have 2 x's here. I'm taking out 1, so that leaves 1 left over. With the y's, I have 3 of them. I'm taking out 2 of them, so that leaves 1 left over. So that's all that's left over in the first term. Now for the second term, negative 18 divided by 9 is minus 2. For the x's, I have 1x, and I'm taking it out, so there's no x's left over. For the y's, I have 2 y's, and I'm taking them both out, so I don't have any y's left over. So I guess I left my parentheses too big, but that's okay if you do. So this would be my answer. Again, if you wanted to check your work, well, it doesn't really check if you took out the greatest common factor. So you might have taken out just a lower common factor. So you do need to take out the greatest common factor. But kind of one of the ways to check to see if you factored correctly is that you can redistribute this, and you should get back to where you started. With 3, again, I'm looking at all 3 terms, and what is the largest number that divides in evenly into 14, 10, and 8? And that would be 2. Okay, with the x's, well, the first one has 1x, the second one has no x's, and the third one has 1x. So because of that middle term, I actually can't take out any x's. So let's move on to the y's. The first term has 1y, the second term has 1y, the third term has no y's. So because of that third term, we actually can't take out any y's. Moving on to the z's, the first term doesn't have any z's. The second 2 terms both have 1 z, but because of that first term not having any z's, we actually can't take out any z's. So we actually can't take out any variables out of this one. That will happen sometimes. So I just want to leave a open parentheses, and I need to factor out this 2. So I'm dividing each of these by 2, so this will be 7xy minus 5yz plus 4xz. And that will be my answer. Lastly, on question number 4, again, I have 3 terms here, and I'm looking at the regular numbers, the coefficients, and what is the largest number that divides in evenly into 15, 3, and 12? And that would be 3. Next, I want to look for the x's. The first one has 4 x's, the middle one has 3, the last one has 4. I'm only as strong as my weakest link, so because this one has 3 x's, or only 3 x's, I can only take out an x cubed. For the y's, this one has 6, this one has 5, this one has 4, so it has to be common to all of my terms. So because this one only has 4 y's, or y to the 4th, I can only take out y to the fourth. So that will be my GCF. Then I need to write what's left over after I factor out a 3x cubed y to the fourth. So 15 divided by 3 is 5. I have 4 x's, I took out 3, so I have 1 left over. I have 6 y's, I'm taking out 4, so I have 2 left over. With the 3 divided by 3, I have a minus 1. I'm just going to put a minus sign. With the x's, I have 3 x's, and I took them all out. With the y's, I had 5 y's. I took out 4, so I have 1 y left. And then on the last term, 12 divided by 3 is 4. I had 4 x's. I took 3 out, so I have 1 x left. I had 4 y's. I took all 4 y's out, so I don't have any y's left over. So it looks like I gave myself too much room again. Again, that's not a big deal. So this would be your answer.